We have discussed the relationship between that angle and that arc, correct? Okay. We have discussed the relationship between maybe that angle and that arc, correct? Okay. What we have not discussed is maybe that angle and that arc, okay? Or that angle and that blue arc, okay? Now, when I create that angle and that blue arc, it also creates the red arc, okay? And then I've got these measurements kind of set up for us. Let me make them a little bit easier to algebraically kind of manipulate. All right, so close to 100. What do you think I can do? So this is close to 100, so let's just round that to 100. Let's round this to 35, and let's round that to, let's just leave it as 32 and a half. What could I do with the numbers of 100 and 35 so that I get 32.5? Or maybe something close to 32 or 33. What could I do with those numbers? Divide what? If I divide 35 by what? Divide 100 by what? Like, or do I divide them both 100 by 35? Well, 100 divided by 35 is 3, right? Close to 3? That's not right. Or do what? Divide what by 2?
The 100 by 33.
No. Maybe if I change them, let me see if we can. Let's see here. What about 50, 18, and 16? 50 and 18. What can I do with those to maybe eventually get something close to 16? Now, I've only got a couple. I could either add these together, multiply them, divide them, whatever. Right? Don't have too many options there in my operations. If I add these together, I get 68, right? Does 68 relate to 16 at all? No. Okay, so subtract 50 and 18, right? What's that give me? 30 something. 30 what? 32. How's 32 relate to 16? Okay, 16 is half of 32, right? So let's see if that relationship exists again. Go back out to this 100. Okay, if that's 100, and this is 35, what's 100 minus 35? 65. What's half of 65? 32.5, right? Is that 32.5? Okay. So I think what we're seeing here is a relationship that says, let me get these things out of there, that when we have this angle on the outside, and we'll talk about what we refer to that here in a moment, we're taking that the measure, I'm just going to call this measure of angle C out here, is equal to 1/2, okay? Let's just call this X, and let's call this red one here Y. Would it be equal to X minus Y times 1/2? Does that make sense? Or if you want to use like the words blue and red, so it's 1/2 blue minus red, okay? But no matter what, that green angle is going to be equal to half the difference of the arcs that that green angle is creating when it crosses through my circle, okay? The order of subtraction matters, okay? So I do 34 minus 100, 35 minus 100, don't I get a negative quantity? And then half of the negative quantity is still a negative quantity, so I say I have a negative angle, and we're not dealing right now with negative angles. We know that 32.5 angle, that green angle should be positive, okay? So when you subtract, it's always the arc that is furthest from your angle. The arc that is furthest from your angle is always the bigger arc, okay? Is that all right with everybody? Okay. Does anybody know what we call that line right there, what kind of line we call it? We've seen this word one other time. This line in the block one is the same thing, but that is referred to as a secant line. Obviously here it's a ray, so a secant ray maybe. But anything that ever says secant, okay, secant is simply a line that intersects a circle. How many times? 2 times. Okay. Sometimes you might see the definition that it is a line that contains, so contains means that there's something inside it, right? What would you call that thing right there? A chord. Okay, so the more geometric, the more mathematical definition you see is that a secant is a line that contains a chord. And when we say line, we really mean kind of any portion of a line that intersects a circle twice, or any portion of a line that contains a chord. So there we're seeing that purple thing's a ray. So let's see, it can be a ray. Now, a lot of times when we say the word circle, we can kind of replace that with the word curve, because parabolas have secants. The sine cosine curves have secants. So secant is really an object, a line that we're going to use a lot in math as you guys go on to other courses. But it's a line that intersects a curve or a circle 2 times. Okay. So that angle C, the way we talk about it or get people to focus on it is we say that it's the angle created by 2 secants. Okay. An inscribed angle had its special name, right? Central angle has a special name. That angle, its special name is the angle created by 2 secants. Okay. Now let's kind of look at some relationships here that happen. Would you guys agree that this is still that black line is still a secant? So that relationship of this angle being half the difference of the arc should be maintained. Is that still a secant? Yeah, if I zoom in, those 2 points, we still have that thing right there that I just highlighted as being a chord. Okay? So that's still a secant. And therefore, we should still have that relationship between this angle being half the difference in those 2. At that stage right there, where those 2 points, I and E, become the same point, this line has become a what? A tangent. Okay? However, we should still be able to take this number, subtract that number, divide by 2, and get that number. Okay? So when you have an angle created by a secant and a tangent, the same formula exists as we used for that picture. Does that make sense? So the formula for that picture is the same for the formula for that picture, which also is the same formula for that picture. Okay. When we have an angle created by 2, what's that line now? Tangent, and that line is a tangent. So this angle is an angle created by 2 tangents. We still have that formula in regards to their difference. So this is kind of wrapping that up. Those are the 3 pictures that we just talked about. The first one is the angle created by 2 secants. The middle one is the angle created by a secant and a tangent. And the last one is the angle created by 2 tangents. All of those have the same formula, 1 half x minus y. Or 1 half quantity x minus y. Okay. Is that okay? We have another set of angles. Okay, so the other angles that we're going to mess around with are these that kind of exist inside here. Okay. We've talked now about every potential angle that we could create on the outside here. Would you guys agree that that last formula kind of addresses all those varying angles that I'm creating right now? Okay. Now, we've talked about all the angles that could be formed when that point is on the circle. And we've talked about all the angles that could be formed when the circle, or that vertex is the center of the circle. We haven't talked about something like that angle, or that angle, or that one, or that one. Does that kind of make sense? So now we want to talk about those angles. And the way we talk about those angles is that we actually take this ray and extend it all the way through the circle. And we take that ray and extend it all the way through the circle. So we extend those two things, and what they end up doing for us is giving us something kind of like this. Now, I messed this up in the last class by showing them something, so let's get back to that. Would you agree that as I move maybe this angle here, let's see here, maybe that angle right there would have been maybe that angle right there in the picture over here. Does that make sense? So when I extend those, we get to this. So this angle is an angle created by two, what's that line called? A chord. And that's a chord, right? So this angle on the interior is created by a set of two chords. Now, let me actually go even a little bit further, or backwards a little bit further, because there we go. So now just to deal with that angle. And let's actually make that arc. So we get to 60. And let's make this arc grow to, or shrink down to 40. Close enough. What do you think I can do with 60 and 40? I get that 50. 60, 40. What do they add together? Give me 100. How do I take that 100 and get 50? Divide by 2. So when I'm interested in that angle right there, its measurement, it is going to be, so if I call that, angle F there, the measure of angle F is going to be 1/2. Let's call that X. Let's call that Y. It'd be 1/2 X plus Y. Very similar to the last formula, right? The last formula was subtraction. This formula, the two arcs that are created by that green angle, and ultimately that green angle's vertical angle. You guys agree that there's a vertical angle there? If I put my cursor, that's terrible. I put my cursor right there. It's that angle, 49.8 degrees. Okay, so the arcs that are created by the angle that I'm interested in on the inside, 49.8 degrees, and the arc that's created by its vertical angle, if we add those two arcs together and then divide it by 2, we will get the measurement of that interior angle. Okay, and that's not only true for that one. Okay, but would you agree that you already know this angle here to be about 130? So if I look at that arc right there, from B to E, and the arc from C to D, if I added arc C to D and arc B to E together, took a half of it, it should give me 130. Okay, now that value is the red one. But we can see that this exists in all these, no matter where I put this. Okay, let's say that I get to try to get to 94. Just to do easy math here, let's get this down to close to 36. Okay, 94 plus 36 should give me 130, right? What's half of 130? 65. Okay, so looking at that, and I'll put this picture up here for you to write down the formulas. It's that theorem right there. that says that measure of angle 1 inside there, okay? Which that angle 1 could actually be a central angle. If it is a central angle, this formula still works. But usually we have a better relationship for a central angle. That angle 1 is now equal to the sum of the two arcs that are created or that are intercepted by those chords. Are those two formulas something we can kind of manage and deal with? Okay. Now there is a question that I want to cover with you guys, and it is something that you guys are directly linked to. This impacts you all the time. Your phones and your GPS and all that kind of stuff links you to satellites, right, that are orbiting the Earth. Okay. And it's not just one satellite; it's a collection of satellites. Okay. Because if I'm at point E, okay, if I got my phone there at point E, can my device communicate to that satellite? It can. So let me see here. Let's see if I've got a sphere. I didn't lock it outside. Okay, sphere, right?
Yeah.
Okay. If you're standing right there with your phone, right?
Yeah.
And your phone is sending signals out, right?
Yeah.
This way.
Yeah.
Okay. And it's actually sending out in kind of a larger spherical pattern. Okay. But if the satellite is right here, where my fingertip is, are those signals going to get to the satellite? No, they're blocked out by the Earth, right? Okay. So that satellite can't see somebody at ease. Okay. So if my phone is trying to find my position on the Earth, doesn't there have to be maybe another satellite up here where my cursor is, and maybe one here, and then one over here, so that at any time I have communication with satellites? Does that make sense? Okay. And we need 4 satellites to actually, I think it's 4, to pinpoint our location. Okay. So at any time when you guys have GPS and you're able to figure out your location, you are communicating with 4 satellites, okay? At least 4. If you're looking at this baseball, can you see the orange dot right here? If there's an orange dot, I'm seeing the orange dot. Can you see the orange dot? You can't see the orange dot, right? Okay. Because you can't see around the circle, right? You can't bend light to see around that circle or that sphere. What if I let me put a dot there and a dot like right there, okay? So I got 2 orange dots, one there where my finger is and one there where my finger is, right? If you're looking at this sphere, can you see those 2 things? No, okay? If you were, let's say that if I'm this is the equator right here, so this would be like the North Pole and this would be the South Pole, right? You cannot see the North Pole and South Pole at the exact same time, okay? So what this is saying is that it wants to know what is that arc length? What is the arc length that the satellite is able, or measurement that the satellite's able to see? Okay. Would you guys agree that this is if I just call this measure of angle S for satellite, that it is equal to 1/2 arc AEB, so that's the arc in the back, minus the arc in the front, arc AB? Does that make sense, everybody? Now, throughout this problem, all you know is that S is 17.5 degrees. So I'm stuck, and I have trouble with these things here because they're not written in this form or in this question, right? But what is that arc, or what does that arc plus that arc add up to? 360. So what if I let this one be X? So AEB would be X, right? Now my minus what would you call this one if x in the blue one, the red one and the blue one, should add to 360? Okay, you could say y, but then I've got an equation with two variables. Let's see if we can do this with an equation with one variable. If you know something adds up to 360, okay, and you know one of those parts, let's say you knew that this was 100, what would this be? It'd be 260. You took 360 minus this 100, right? So we don't know this to be 100, we just know it to be x. So wouldn't this be 360 minus x? So now, so arc AB, when I subtract arc AB, it's 360 minus x. That is going to change to 17.5 is equal to a half x minus a quantity. What's x minus 360? Be negative 360, right? And then minus a negative x. What's minus a negative x? It's plus x. So now I get, 17.5 times 2 is 35. And then here I'm going to get 2x minus 360. I'll add 360, so it gives me 395. It's 2x. X ends up being, I think it's 197.5. So that is from A to E to B is 197.5 degrees, making the blue one 162.5 degrees. And that's what we're looking for. And that should make sense because you can't see the North Pole at the same time you see the South Pole, right? If you could see those, that blue arc would be what? 180. And it's a little bit less than that, right? Okay? So you'll see a question similar to that, and you might even see one of those on the course at the end. They like to do that type of thing on that test. But you have to manipulate the two unknown values. It'd be really easy if they gave you one of those arcs, right? But you got to use the fact that you know the total to kind of develop both of them on your own. There's an assignment in Math Excel. It's not due until Friday, so don't worry too much about tonight. There's some stuff in there that we haven't covered. Huh? No, not in this one.
Oh my gosh.
Have a great day.